Number 7, we're asked to find the gradient vector field for this function. And so that's pretty straightforward. Just gradient f is the partial of this with respect to x, partial of this with respect to y. And then sketch 6 of the vectors. Well, it's pretty easy to sketch them. I'll just use the points, my x's and y's. I mean, it's easy to do 9 of them. I can go -1, 0, 1, -1, 0, 1. You just have to do 6. What I'm going to get here when I plug in -1, and for both of them, they're just going to be -1, -1. And then when I plug in 0 for x, that's actually going to give me the 0 and the y, so it's going to give me -1, 0. Plugging in 1 for x, I'm going to get -1, 1. And then plugging in 0 for y, that's going to be my first component now, 0, -1, and 0 for both of them. And then this plugging in 1 for x and 0 for y is going to be 0, 1. And like I said, I'll just do this last row. This is going to be 1, -1. This is going to be 0 for x, 1 for y, so it's going to be 1, 0, and 1, 1. So if I want to plot that vector field, just at least those 9, here's kind of the grid that I'm using. I'm going to do one at 0, here, here, here. You can stop there, but I'm going to go ahead and do 9 of them. All right, so at -1, -1, I get the vector -1, -1. That means it points -1 in the x, -1 in the y. So it would be pointing, oh, sorry, -1 in the x, -1 in the y. So it's going to be pointing here. And then let's go -1, 0. So that's this one. That's pointing 0 in the x direction and -1 in the y. So something like that. And then this one is pointing -1 at -1, 1 is pointing -1 in the x, and sorry, +1 in the x, and -1 in the y. So it's pointing there. Okay, I think I got those right. Next, I got 0, -1. 0, -1 is here, and I'm going to plot -1, 0, so it's going that way. Then I've got 0, 0. There's nothing happening there. Then at 0, 1, that's here, it's going 1, 0, so it's going there. And then the last one, at 1, -1, this is going -1 in the x, but 1 in the y, so it's going to be there. And then at 1, 0, it's going 0 in the x and 1 in the y, so that's going to be going there. And then finally, at 1, 1, it's pointing 1, 1. So nice and symmetric looking. If you actually use CalcPlot, you'll see a better sketch of what's going on. But that's why I did 9, just so it would be a little nicer looking. Anyway, that's your vector field, your gradient vector field. Number 8 says evaluate this line integral. And it's a scalar line integral because there's a scalar function inside the integrand here with respect to where the curve is a circle, but only lying in the first quadrant. So I'm going to integrate just that part of my circle. It's got a radius 2. Well, I just need a parameterization of that circle. And we know that cosine and sine will do that, but I got to have a radius of 2, so that means I actually have to put 2 in front of that. And that's because if you square both of these and add them, you'll get 4 cosine squared plus 4 sine squared, factoring out to 4, that gives you 4. So it gives you the radius of, the radius squared, which is 4. So, calling that x and that y, squaring those, adding them up, you're going to get x squared plus y squared equals 4. So you do need that 2 in front. R prime is going to be -2 sine t, 2 cosine t. And so now my integral becomes the integral, and I need to put the integral down here. I just wanted to stay in this first quadrant. Notice if I start at 0, I get 2 and 0. That's where I want it to start. And then I got to stop it at pi over 2, and that'll swing it through the first quadrant. So I'm going to go from 0 to pi over 2. And I need to incorporate my r, which is going to give me 2 cubed, which is 8, times cosine cubed. And then I'm going to get 2 cosine times 4 sine squared. So that's going to be 8 cosine sine squared. So it's that times the magnitude of r prime. Well, that's the square root of 4 sine squared t, squaring the 2 and the sine, plus 4 cosine squared t dt. So what happens here, inside this square root, is you can factor out the 4, you get sine squared plus cosine squared. This is just going to be the square root of 4, which is 2. Over here, I've got an 8 that I can factor out of both of these. Along with the 2, there's going to be a 16 out in front of this. And the square root's gone. And now, with the rest of this, I can factor a cosine out, and it leaves me with cosine squared plus sine squared. So reusing that identity over and over. I get 1, so this is just the integral, 16 times the integral of cosine. Well, cosine, you get sine when you integrate, and that's going to be from 0 to pi over 2. So plugging it in, you get 16 sine of pi over 2 minus sine of 0. And sine of 0 is 0. So and sine of pi over 2 is 1. So this is just 16.